So we're going to do some more problems this time with the review sheet you got. This time we're going to concentrate more on the proofs and proving certain things, either if it's a parallelogram or what's inside of a parallelogram. So for this first proof, they give us this figure. And they go ahead and tell us in the given statement that it is a parallelogram. And they also tell us that EC is equal to AF. And I went ahead and did the tick marks to show that those are the same. And they want us to prove that the triangle EGC, which is this triangle right here, or just triangle, is congruent to triangle FGA, which is this triangle right here. So what I saw first, it's like, okay, they gave us the EC equals AF. Well, I went straight to making those congruent, because if they're equal, then they are congruent. After that, I went to these angles. I saw them as vertical angles, in which they are. So because they're vertical angles, they too are congruent. So already you have a side and an angle. Alright, next step. So properties of the parallelogram. Opposite sides are parallel. And then you have a line going through it like that. So the angle DCA and angle CAB, those are considered alternating interior, which you learned when you did parallel lines and then lines intersecting the parallel lines. So you can use that as a reason to make GCE congruent to GAF. Just like that. And with that, with those three components, you have that the triangles are congruent because of angle, side, angle, which you just can change to angle, side. You have angle, angle, side, and you can change it to angle, side, angle. So that was a pretty quick and easy proof. So this next one that we're going to do is a little more difficult, but they want us to do a flow proof for this one instead of a normal proof. And what they give us are coordinates for a quadrilateral. And the reason I said quadrilateral and not a parallelogram is because they want us to prove that this quadrilateral is a parallelogram. So what I went ahead and did first was I went ahead and drew a little picture. And so I just got the first quadrant, because all of these are positive. I went ahead and used only the first quadrant. And I plotted each of the points. And I connected the points and made the quadrilateral that they asked for. So, and they did mention in the problem that they wanted us to use the property that diagonals bisect each other. So that is why I drew in the diagonals. The diagonal BD and the diagonal AC. And they do, a way that you can prove that the diagonals bisect each other is with the midpoint. They share a common midpoint. So I went ahead and put this point right here, this is an M for midpoint. I went ahead and showed that right there. Alright, so my first thing is I found the midpoint for each of them. So I found the midpoint of AC using x1 plus x2 over 2 and y1 plus y2 over 2, the average of the x and y values, and I got 4, 2. And then I found the midpoint of BD using the same way, the average of the x and y coordinates, and I got the same midpoint. So that gives us to our next box. Diagonals have the same midpoint, which implies that they bisect each other. And from there, you can go ahead and go right into quadrilateral ABCD is a parallelogram. Okay? So that's it. I mean, that's as simple as that. So just remember that if they give you coordinates and if you're able to use the diagonals, then use them and find the midpoints, because that is a great way to go from a quadrilateral to a parallelogram, is if they bisect each other. And the easy way to seeing if they bisect each other is the midpoint, because the midpoint separates it into two equal parts. Alright? Hope that helps.